quenching is a logical choice for gears. Atmosphere and vacuum carburizing carbonitriding of gears, followed by oil quenching, is a popular choice among manufacturers to achieve consistent mechanical and metallurgical properties and predictable distortion patterns. The reason oil quenching is so popular is due to its excellent performance results and stability over a broad range of operating conditions. Another important advantage of oil quenching is that it minimizes the tendency to cause distortion and cracking. Quenching in still, non-agitated oil is often used as a means of distortion control on critical parts. Gear manufacturing is an art that can be mastered only by truly dedicated professionals. It takes years of practice and a plethora of modern machinery for an average gear manufacturer to produce flawless results. This is why businesses choose to work only with professional gear manufacturers with a proven track record. Gears are indeed the unsung heroes of countless industries, quietly working behind the scenes to keep the machinery running smoothly. For forging huge gear shafts up to 35 tons. We used to hydraulic 4-column upsetting presses with pressing forces of up to 14 meganewton, moved by rail-bound and mobile manipulators with up to 50 tons of lifting capacity. Heavy parts, such as drive charts with extreme dimensions, are forged here and shaped to precision in one single operation. An electronic control unit supports the press operator. Ring rolling is a hot forming process that produces seamless rings varying in size from a few inches in diameter and weighing less than 1 pound to over 25 feet in diameter and face heights approaching 10 feet. The workpiece prepared when a cylindrical piece is cut, flattened, and a hole is made in the center. After heating, the workpiece is rotated between an inner and the outer roller and between two conical rolling pins. The workpiece is compressed between the rollers such that its thickness in the radial direction decreases, but the workpiece volume is maintained throughout the process. Instead, the diameter increases. Plan rolls has the task of ensuring that the workpiece upper and lower plane is maintained in parallel. Automatic ring rolling production line. The fully automatic ring rolling line is composed of induction furnace, 3-position power press, industrial robot ring rolling machine. Hot extrusion is the production process used to form special steel profiles with a constant longitudinal cross-section. It acts through a force called compression. This process can be employed to manufacture solid or hollow profiled bars with complex geometries and a fixed cross-section in a single step. The material is compressed by the punch on one side and then exits on the opposite side, where the die is located. Modern manufacturing processes and innovative machinery. Ability to transform and process high alloy steels and titanium. Creation of complex shapes, both solid and hollow. Shapes not obtainable with other processes. Cross-wedge rolling is an economical and effective way to produce preforms with variations in cross-section diameters. The process rolls the workpiece between rotating dies to create various diameters across the length of the workpiece. Advantages: reduce technology development cost by testing on your computer without no need to produce test equipment or perform trials on a rolling machine. A metal haping process in which a malleable metal part, known as a billet or workpiece, is worked to a predetermined shape by one or more processes such as hammering, pressing. The workpiece is heated up to about 75% of its melting temperature. The process begins with a cast ingot, which is heated to its plastic deformation temperature, then forged between dies to the desired shape and size. During this forging process, The cast, coarse grain structure, is broken up and replaced by finer grains, achieved through the size reduction of the ingot. Usually, the product is additionally heat-treated after it is hot forged. Hot forging results in metal that is stronger than cast or machined metal parts. Thus, hot forging technology has a special place in producing parts of superior mechanical properties with minimum waste of material. Furthermore, as the temperature of the workpiece prior to forging approaches the melting temperature, the flow stress and energy required to form the material are decreased. Therefore, the strain rate or production rate can be increased. Therefore, many hard metals with properties of cold working hardening or that can be strengthened by heat treatment are forged hot, such as iron and its alloys. Alloys that are amenable to precipitation hardening, such as most of titanium alloys, can also be hot forged and then hardened.